On December 5, 1952, a nauseating yellow-gray fog engulfed London, claiming 12,000 lives. This wasn't mere mist, it stank of rotting eggs and stretched 30 miles wide. Buses halted, planes were grounded, and ambulances were trapped. For 5 days, the city vanished in the stench and sludge, streets slick with a black ooze. Those who dared ventured out stumbled blindly, smudging their faces while birds crashed into buildings. With visibility zero, thieves ran rampant, and even indoor shows were canceled. The Great Smog sent over 100,000 people to hospitals, leaving a grim legacy of demise and decay. The causes of this tragedy started long into the past. Something called pea soup fog became one of the symbols of London in the 19th century. Nature wasn't to blame for this fog. It was caused by people burning coal to heat their homes and run factories. In fact, London's air started getting smoky all the way back in the 13th century, when people began widely using coal. It got worse as the city grew bigger. By the 17th century, people were already complaining about the dirty air. King James I tried to prevent so much coal burning with new laws, but nothing really changed. As more factories popped up during the Industrial Revolution in the late 18th century, the problem blew out of proportion. The air was full of tiny particles that water clung to and formed dark, heavy clouds. This mix of smoke and fog became so bad, people called it smog. Yep, this word was invented in London in the early 20th century. The smog got so thick sometimes it could last for a whole week, and it made people ill. Some even passed away because of it. Even though the smog was harmful, people didn't want to stop using coal because it gave them jobs and kept their homes warm. So the problem lingered. By the 20th century, thick fogs were happening less frequently, finally, because factories started moving away from the city. But on that December day in 1952, an anticyclone appeared over London. This meant that the cold air near the ground got trapped under warmer air higher up, like a lid keeping everything underneath. Because of this, all the smoke from factories, cars, and home fireplaces couldn't float up and away like usual. Instead, it clung near the ground, mixed with water in the air, and produced an extremely thick, dirty fog. Plus, daylight in December is shorter, and it was really cold, so people had to use even more coal for heating and lighting than they normally did. All this led to a disaster. It was clear that sulfur particles from the burning coal made the fog yellow and smell like rotten eggs. But scientists couldn't figure out why and how these particles turned into sulfuric acid. Decades later, an international team of researchers recreated that scary fog in a lab. They used samples of air and atmospheric measurements from the fog in 2 large Chinese cities that have high levels of sulfur dioxide in the air, just like London during the Great Smog. They learned that the thick, dirty air, called haze, doesn't form in the same way in London and in China. In London's fog, smoke from burning coal released 2 gases, sulfur dioxide and nitrogen dioxide. These gases mixed with water droplets in the fog, which made it harmless at first because the water diluted the harmful chemicals. But as the water evaporated and there was nothing to dilute the 2 dioxides, the fog became very acidic and hazardous to breathe, so it damaged people's lungs. In present-day China, things are a little different. A third chemical, ammonia, joins the mix. Now ammonia, which comes from farms and cars, helps balance out the acidity of the fog, so it's less harmful than London's deadly fog. But the scientists found that cutting down on nitrogen dioxide and ammonia could still help China reduce its air quality problems. They hope that their discovery will help both understand London's past fogs and give China ideas for making its air cleaner. It could also save the health of millions of people around the world who are now living in cities with bad air quality. After the terrible fog of 1952, everyone realized how serious London's air problem was. 4 years later, the British authorities created a law called the Clean Air Act to stop something like that from happening again. This law banned people from burning smoky fuels like coal in their homes or in factory furnaces in some parts of the city. To help people adjust, the authorities gave them money so that they could switch to cleaner heating options, like oil, natural gas, or electricity. It took time for these changes to make a big difference, and sadly, another dangerous smog happened in 1962. But the Clean Air Act was a very important first step for protecting the environment and people's health. Almost a century before the Great Smog, another smelly event happened to London, the Great Stink. Back then, people didn't have proper bathrooms or sewers, and all the waste from houses and factories went straight into the River Thames. When the weather got super hot in July and August, the water level in the river went down, and piles of waste, sometimes 6 feet, popped up on the muddy banks. The smell was so terrible that even Queen Victoria and Prince Albert had to cancel their relaxing boat ride on the river. The politicians working in the brand new Parliament buildings, which were right by the river, couldn't handle the smell either. The air inside was so terrible that they had to hold handkerchiefs over their noses to breathe. They even tried soaking the curtains in chloride of lime, hoping it would cover up the horrible odor. Many Londoners believe that the bad air, called miasma, caused horrible things like cholera, which had already taken the lives of lots of people. Engineer Joseph Bazalgette solved the problem as he built a new sewer system that would move all the waste away from the city. His sewer system was so well designed that it still works today, even though London has grown to over 8 million people. On the other side of the Atlantic, in the United States, there was also a day when you couldn't see your hand before your face, and it was impossible to breathe outside. But the reasons for this Black Sunday were very different from the Great Smoke of London. In 1931, it almost completely stopped raining in the southern Great Plains. This drought lasted for nearly 10 years. Without rain, the farms dried up and the soil turned to dust. Strong winds blew this dry dirt into the air and created huge dust storms. These storms, called black blizzards, made it hard to breathe and see anything. People tried to protect themselves by putting Vaseline in their noses, wearing masks, and sealing their homes, but the dust still made many of them sick. In 1934, things got even worse. It was the driest year in over 1,000 years. Temperatures went over 100 degrees for weeks, and the land became even drier. On April 14, 1935, after months of terrible weather, the sky finally looked clear, and there was barely any wind, which was rare for this area. People came outside as they were hoping that the worst was finally over. When Oklahoma minister announced that a few good rainstorms would make the land fertile again. But unfortunately, that morning, a cold wind from Canada met warm air in the Dakotas and started a massive dust storm. The storm grew to hundreds of miles wide and thousands of feet tall. A sunny day instantly became completely dark. Drivers had to hide in their cars, and other people went down into basements, found refuge in barns, fire stations, tornado shelters, and under their beds to stay safe. The storm didn't stop for hours and took at least 20 lives. Many people couldn't stop coughing, and one man went blind. The storm was so strong, it carried 300,000 tons of dirt across the country and even reached the East Coast.
This is the London Underground mosquito. Hank Marvin, pleasure to meet ya. To come across this buzzing little bloke in person, you'll need to travel to London and specifically head down into the subway. Chocker down here, isn't it? Because among 3,000 species of mosquitoes in the world, you'll only find this guy in the London subway. Not buzzing above ground near the stations, but down in the system. This mosquito is one of those rare cases when a unique species evolves in one particular place. They built the system back in the 1860s. It's the oldest subway in the world, mind you, and any mosquitoes that happened to be down there got shut off from the rest of the world. Save for the entrances and exits at stations, the subway system is a pretty sealed environment. The mosquitoes got trapped and evolved right there. And if you're annoyed by all mosquitoes in general, get this, the London Underground species is even bitier than others. While above-ground mosquitoes mostly feed on birds and grab a bite from you when given the rare chance, this one really likes to go for people. That's because it made do with the meals available to it, not birds, but mammals. That is, rats and humans. It's also unique in that it doesn't need blood to lay eggs like other mosquitoes, and doesn't hibernate in the winter, so expect to swat at them year-round. Also a result of their being secluded to this underground tunnel system, no obvious seasonal temperature changes down there. This London type is so unique that it can't even crossbreed with other mosquito species. But beware, this species could be on the move. Infestations of particularly bitey mosquito populations have popped up in subway systems and sewers around the world, from Melbourne to New York. So let's head across the pond and meet another bug that lives only in the big city. Of over 1 billion ants running through the streets of Manhattan, scientists spotted a unique reddish-brown variety. That's about 120 ants for every person living in New York. These insects don't fit into any of the 13,000 ant species known to science. They're unique and only live in Manhattan between 63rd and 76th Streets. Scientists don't know how long these so-called Manhattans have evolved in isolation. They arrived in the US on ships from Europe and were cut off from the rest of the city's infrastructure. One thing's for sure, the species thrives on fast food, especially corn syrup. Because of its carbon-rich diet, the Manhattan was able to perfectly adapt to the dry, warm weather of the concrete jungle. Both ants and mosquitoes lived with dinosaurs. But don't get too excited about cloning a T-Rex by taking blood from a fossilized mosquito. We'll leave that myth to Hollywood plots. DNA is an incredibly fragile molecule. It breaks down quickly. So you'll need a mostly fresh sample from a recently departed dino. Chances are, we can't bring the dinosaurs back. But no need to. Dinosaurs live among us today. Everybody thinks an asteroid wiped out all the dinos 65 million years ago, but it didn't. Some survived and evolved into creatures you see every single day. Birds. In fact, the closest living relative to the mighty T-Rex is the chicken. Tarantulas in the wild keep tiny frogs as pets. Well, they don't feed them or take them for walks, but they do let the little froggies hang around with them. It's a win-win relationship. The frog gets a big hairy bodyguard from things that want to eat it, and the tarantula gets a protector for its nest. These tiny frogs feed on ants that try to eat the spider's eggs. There's no distinct border where our atmosphere ends and space begins. As you go up and further from the surface, the air gets thinner and thinner. At some point, it loses enough density that airplane wings stop working. That's about 60 miles up, and where scientists decided space officially starts. Yes, the cosmos is just an hour's drive away. The photoreceptors in your eyes are so sensitive, they can project an image when it's not even there. Ever stared at a bright light, moved your eyes to something else in the room, and you can still see the shape of that light bulb floating before your eyes? That's your eyes continuing to send visual information to your brain. A healthy human eye can see a candlelight up to 30 miles away. The Mariana Trench, the deepest known place on this planet that could fit Mount Everest with room to spare, goes only 6 miles down. The leaf slug eats so much algae, their body absorbs a part of the plant cells, chloroplasts, that let these little guys actually photosynthesize. Basically, this sea slug is part animal and part plant. When you dream, the props come from those older parts of the human mind that refer more to genetic memory than to your own personal ones. Smartphones and cars came into our lives in relatively recent times, and our cave people brains haven't gotten used to them enough. That's why you hardly ever see tech in your dreams. Okay, say you're one of the lucky few who's used a phone in their dream. Did you struggle to read or write a text? It's because the two regions of your brain that help you interpret language are mostly inactive when you're asleep. It's a good trick to know you're in a dream. You won't be able to read words or tell the time on a clock. Imagine if we could record a black hole on video. Watch it pull in and consume any matter that gets too close, even light itself. Oh, spaghettification. Now take this recording and play it backwards. This is what a theoretical white hole should be. The black hole's pushing away and matter spewing counterpart. If you've seen videos of whales surfacing, you'll notice they spray water from their blowholes. Only they don't. Whales are mammals like you and me. They breathe air. That's why they come to the surface. They release old air they've been holding in their lungs and take in new fresh air. That warm air coming from the blowhole meets with cold air around it and forms water droplets, giving the illusion that blowholes are like fountains.
Get equipped for any season with brand new Brightside merch. Click the link and grab your print.
You can tell a whale's type by looking at its blowhole. If it has two nostril-looking holes, it's a baleen whale, the kind with teeth that look more like toothbrush bristles. One blowhole means it's a toothed whale, which includes dolphins and orcas. The mighty megalodon was over half the length of a blue whale, the largest creature that's ever lived in all of Earth's history. Scientists did a computer calculation of a meg's bite force and came up with something like 18 tons per square inch. That's over 10 times stronger than a great white shark's, and enough to crush whale bones like a grape. Thanks to cell regeneration, you replace your skin entirely every month, your blood every 4 months, your liver 500 days, and you make yourself a whole new skeleton every 10 years. Scientists think we yawn to get more oxygen to the brain. When you get bored or tired, you don't breathe as deeply, and it starves the brain a little. The lungs expanding and stretching the surrounding muscles also helps wake the body up. Cicadas are totally unique on this planet in that they have no natural enemies. Since they come out of their underground shelters every 13 or 17 years, no other animal can depend on them as a food source. Scientists believe that early humans lost their fur so they wouldn't overheat while hunting. We instead evolved to store fat to keep warm, which is why your head is covered in long, thick hair. There's no fat on your scalp. A teaspoon of neutron star material weighs 10 million tons. That'd be like squishing millions of Earths into a ball the size of Manhattan. If you could stand on the surface of a neutron star, your body would be instantly squished down and spread into a layer 1 atom thick. Yep, you'd be two-dimensional, just like a cartoon. Get this. 1 million seconds is about 11 days. 1 billion seconds is 30 years. 1 billion steps would take you 15 times around the Earth's equator. And if you started counting from 1 to 1 billion right now, it would take you 95 years to finish. Okay, let's get started. 1, 2. 1 dog year equals 7 human years. That's an oversimplified and widespread myth. Aging in dogs and cats can depend on the breed, size, and their age. For example, 1 year for most dogs equals about 15 human years. That jumps to 24 at age 2 and slows down to around 4 more human years with each birthday. It then speeds up yet again after their first 6 years, especially for larger breeds. Most animals have tails, so why don't humans? It's because we started walking on 2 legs. Tails help with balance, but when your body mass is upright with that 10-pound head sitting on top, you don't need another appendage at the other end to balance it all out. If you're ever on a plane and the landing feels like it was accidentally rough, it was probably done on purpose. A plane's wings produce more lift when they're closer to the ground, pushing it back up into the air. The best way to prevent this is with a firm landing that puts the wheels on the runway as soon as possible. Harder landings also give the wheels more traction on rainy or snowy runways. If your second toe is longer than the big one, you're pretty special. Only 1 in 10 people have this so-called Morton's toe. In ancient Greece, a foot with Morton's toe was considered a sign of beauty. By the way, the Statue of Liberty has it too. Contrary to popular belief, the tongue is not the strongest muscle in your body. That would be your jaw muscle. Plus, the tongue isn't technically a muscle, it's 8 of them woven together. Structurally, it's very similar to an octopus arm. Nope, that wasn't a slip. An octopus does have arms, not tentacles. And they only have 6 arms. The other 2 are legs. Arms have suction cups all the way down their length. Tentacles only have suction cups at the end, and that's what squids have 2 of. If you could open your head and poke your brain, you wouldn't feel anything. It might be the powerhouse of the nervous system, but it doesn't contain any sensory receptors for contact stimuli, aka it doesn't feel pokes and prods. Horse hooves and rhino horns are made of the same stuff as your hair and nails, keratin. Rhino horns curve back because the keratin in the front grows faster than in the back. One of the oldest tips out there is to run from a crocodile in zigzags, since it's hard for the animal to turn around quickly and follow you. This is just a complete myth. Just run in a straight line as fast as you can. Don't bother climbing a tree either. Crocs can climb those too. Don't ever practice your dunking skills on Comet 67P. Its gravity is so weak, your jump would surpass its escape velocity. That's the minimum speed you need to escape the pull of gravity, like rockets blasting off Earth. On this comet, you jump up and go floating off into space. There's a species of giant earthworms that can grow as long as your leg. They live specifically in the Palouse prairie lands of Idaho and Washington. Oh, and these ginormo worms smell like lilies. Dinosaurs had fleas the size of cockroaches. Well, they weren't technically fleas because they couldn't jump high like the modern day ones. But they could get their mouth parts through dino skin. If you swallow gum, it doesn't stay in your stomach for 7 years. That's a myth. Sure, your saliva and stomach acid can't break it down, but the muscles of your digestive tract move it along, and it makes its exit in a day or 2. Mosquitoes can live perfectly fine on flower nectar instead of your blood, and it's only the females that bite humans, and they do it because they need a protein found in blood to produce eggs. The largest flower in the world also happens to be the stinkiest. With a bloom about 3 feet across and weighing roughly 15 pounds, the corpse lily smells like rotting meat. Sharks are the only fish that can blink with both eyes, but it's not to clean or hydrate them. They blink to protect their eyes while biting into their lunch. The average cumulus cloud, that's the big poofy kind, weighs just over 1 million pounds. That's the weight of about 100 fully grown elephants floating above your head on a cloudy day. If you shout in space, nobody will hear you. It's because there are no molecules in the vacuum of space for the sound waves to travel through. Dark and light look way more contrasted on the moon. On our planet, the atmosphere diffuses sunlight, so objects remain a little illuminated in the shadows. The moon has a next to nothing super thin atmosphere, so shadows are blacker. But when there's light, it shines on the moon much stronger because of its reflective dust. We went to the moon before wheels were added on suitcases. That second giant leap for our species happened a couple years later. The light stars emit is constant and steady. The Earth's atmosphere interferes and makes it look as if they're twinkling when they're not at all. Information moves along nerves at about 200 miles per hour, getting from one place to another in a matter of milliseconds. That's why you jerk your hand back so fast when you accidentally touch that hot pizza pan. Electrical sockets look different around the world, but they all have one thing in common, at least 2 holes. It's because electricity must flow through a circuit, or a kind of circle. The current flows from your breaker box to the hot hole on the right, passes through the appliance, say your hairdryer or lamp, and then comes back to the neutral left hole. A blue whale's heart is the size of a golf cart and can weigh 400 pounds. Your heart weighs 10 ounces. That makes a blue whale's heart 640 times larger than a human's. But the one with the biggest heart compared to body size amongst all animals, it's your loyal, loving dog. People getting their picture taken during Victorian times said prunes instead of cheese. Shaping the mouth this way apparently gave them a nobler look. Plus, it could take 15 to 30 minutes just to take one photo. Imagine holding a smile for that long. Cleopatra lived closer to the release of the first iPhone than to the building of the Great Pyramids. When the first dinosaur fossils were discovered in the 1670s, people had no idea what they were. Their best guess, the bones belonged to an extinct species of giant humans. Fossils also show that 40 million years ago, penguins were the size of a kangaroo. The world's largest waterfall is underwater. This is the Denmark Strait Cataract, where cold, denser water from the Nordic seas flows under warm water from the Erminger Sea. Along the way, it falls 11,500 feet over an underwater ridge. That's more than 3 times the height of the tallest waterfall on land. Australia is wider than the moon. Check the numbers. The land down under is almost 2,500 miles across. The moon, a little over 2,100. It took Rubik's Cube creator Erno Rubik 1 month to solve the cube after he created it in the early 70s. The world record today is 3.47 seconds. Lightning is 4 times hotter than the sun. A single bolt can toast over 100,000 slices of bread. Pineapples have a digestive enzyme in them, so when you eat a pineapple, it eats a little bit of you too. That's why it burns a little in your mouth when you bite into one. No worries though, your stomach will always come out the winner in this match. Disposable chopsticks are connected at the top, so you know they haven't been used before. You're supposed to break that connected top off and lay your used chopsticks on it so they don't touch the table. The main function of eyebrows is to protect your eyes from sweat and dirt. That's why they grow toward your temples, to direct moisture to the sides, instead of straight down. But they also protect your eyes from too much sunlight. Without brows, our species probably would have evolved to have really long, thick eyelashes. An average person will grow 600 miles of hair in a lifetime. That's about the distance from New York City to Dayton, Ohio. Point Nemo in the Pacific Ocean is the most remote place on our planet. It's more than 1,600 miles from any coast. If you traveled there, you'd be much closer to astronauts on the International Space Station than to any human on Earth. The ISS orbits just 250 miles above the surface. Watching paint dry is a profession. You sit in a chair in front of a freshly painted wall, and, well, you get it. Your job is to track how the paint texture changes, where it cracks, and give a detailed report based on your thrilling observations. When people used sundials in ancient times, the shadow of the sun went from the left to the right in the northern hemisphere, and vice versa in the southern hemisphere. The first mechanical clocks were invented in the north, so they go with what we now know as clockwise. If it had been in the south, the directions could have been switched today. The body's fastest muscles are in the eye, and the blink of an eye is about 1/10 of a second. You do that 20,000 times a day. Next time someone says, "I'll get it done in a jiffy," remember this: scientists say a jiffy is the time light needs to travel 1 centimeter, about the width of your fingernail, in a vacuum. Human fingertips are so sensitive, they can feel ridges in an object, even when they're just 13 nanometers deep. A nanometer is 1/1,000,000th of a millimeter, and a millimeter is about the length of a grain of sand. In 1992, a cargo ship lost a crate with 28,000 rubber duckies in the North Pacific. These toys still appear on coasts around the world, even over in the Atlantic.
The Boxing Day tsunami, Indonesia. An undersea earthquake starts in the morning. Its tremors cause a series of tsunami waves. The largest reaches the height of the Arc de Triomphe in Paris. Unzen volcano mega tsunami. A powerful volcanic eruption triggers a landslide from a 4,000-year-old lava dome. It sweeps through the city of Shimabara and reaches the sea, setting off a mega tsunami. The Vajont Dam mega tsunami, Italy. A landslide drags 9 billion cubic feet of forest, soil, and rock into the lake. A dark wall of water covers the sky over a tiny village at the bottom of the Vajont Dam. Then, with a deafening roar, the wave overtops the edge of the dam, taking out everything in its path. Mount St. Helens mega tsunami, USA. As the volcano erupts, The upper 1,500 feet of Mount St. Helens collapses into a massive landslide. Part of this avalanche plunges down into nearby Spirit Lake, which splashes the lake waters into a series of waves almost as tall as the Eiffel Tower. Alaska's Lituya Bay tsunami. A landslide caused by an earthquake creates a megawave. It surges over the headland and washes away trees, plants, and soil down to bedrock. Molokai, Hawaii. A third of the East Molokai volcano caves in and collapses into the Pacific Ocean. This causes a tsunami the size of the second tallest building in the world, Shanghai Tower. The waves reach Mexico and California. The Yucatan asteroid tsunami. The asteroid, which is rumored to have wiped out dinosaurs, strikes the Yucatan Peninsula. It creates a mega tsunami, the largest in Earth's history. The first wave's almost twice bigger than the world's tallest building, the Burj Khalifa. Hurricane Mitch. Mitch forms in the western Caribbean Sea. Soon it strengthens to become the 8th most powerful Atlantic hurricane ever. The storm pours 4 inches of rain per hour for 2 days in Honduras. It causes terrible mudslides and floods. Hurricane Allen. Rare and extremely powerful, the storm is one of the few to reach Category 5, the highest possible. It causes more than $2 billion in damage. The Great Hurricane. After tearing down Barbados, the storm moves on. It strips the bark off the trees growing on Martinique and St. Lucia and travels further. This horrific natural disaster lasts for 6 days. Hurricane Dorian. It's the most powerful tropical cyclone to hit the Bahamas. The hurricane flattens most of the structures on the islands and sweeps them into the sea. Hurricane Wilma. The storm occurs in the Caribbean Sea near Jamaica and heads to the west. 2 days later, it gathers enough power to turn into the most intense hurricane ever recorded in the Atlantic Ocean. Hurricane Patricia. A regular storm develops a well-defined eye and turns into a Category 5 hurricane within a mere 24 hours. At one point, it travels faster than a Ferrari moving at its top speed. It makes Patricia the world's most intense tropical cyclone ever recorded. Kamchatka earthquake. It happens in the early morning 80 miles away from the shores of Kamchatka. The earth tremors produce a tsunami. The first 2 waves are catastrophic, up to 60 feet high. The third one's much weaker. Valparaiso earthquake, Chile. It happens at about 5 a.m. along the boundary of 2 tectonic plates. The tsunami, triggered by the earthquake, wipes out 620 miles of Chile's coastline. Tohoku earthquake, Japan. The first earth tremors start at a great underwater depth. The earthquake is so strong it moves Japan's main island. It shifts the planet on its axis by up to 10 inches and increases its rotation speed. The disaster also triggers a tsunami with 133-foot high waves that travel 6 miles inland. Indian Ocean earthquake, Sumatra. A rupture along 2 tectonic plates sets off an undersea earthquake. It begins at about 8 a.m. near northern Sumatra, Indonesia. It makes the planet vibrate nearly a half inch and sets off earthquakes all over the world up to Alaska. Good Friday earthquake, Alaska. The most powerful earthquake recorded in North America lasts for 4 minutes and 38 seconds. A 600-mile-long crack causes terrible landslides and a 27-foot tsunami. Areas 200 miles away get raised by 30 feet. Other places permanently drop 8 feet. Valdivia, Chile. The Great Chilean earthquake starts in the afternoon and lasts for no less than 10 minutes. The disaster affects an area the size of California. It triggers tsunamis that reach the shore of Hawaii, Japan, the Philippines, Australia, and New Zealand. The average tornado usually lasts less than 10 minutes, but there are exceptions. El Reno tornado. It's considered the world's largest tornado based on width. At its peak, the twister reaches 2.5 miles across. The Perryville tornado, U.S. It occurs at about 2 a.m. and starts with snapping hardwood trees and breaking down stone constructions. Then the whirlwind becomes stronger. It levels 2-story buildings, flips and tosses cars as if they were toys. Bridge Creek Moor tornado. When the twister gets into the town of Bridge Creek, its width is at its peak, 1 to 1.5 miles. The wind speed of the tornado reaches more than 300 miles per hour. This natural disaster causes $1 billion in damage. Manitoba, Canada. An outstanding tornado rages for nearly 3 hours. It breaks tons of trees and utility poles, damages roads and farmhouses, but miraculously misses every town on its path. Tri-state tornado, U.S. The world's longest-lasting single tornado travels 220 miles through Missouri, Illinois, and Indiana. The average tornado's path is usually no longer than 5 miles. Tupelo, Gainesville, U.S. An outbreak that consists of at least 12 single tornadoes wipes out everything on its way. The accompanying rainstorms also trigger severe flash floods that make matters even worse. Valjean landslide, Italy. At 10 p.m., a landslide with a volume of 100 Great Pyramids of Giza breaks off from the top of Monte Toc. It falls into the Valjean Dam reservoir, producing a tsunami wave taller than the Golden Gate Bridge. Yunnan, China. An avalanche of rocks, stones, and mud, so big it could fill up Sydney Harbor, forms a dam on the Jinsha River. The Hida River, Japan. Triggered by a rainstorm, 300,000 Olympic swimming pools of debris flows down before getting stopped by another, earlier landslide. Along the way, the landslide sweeps 2 buses off the road. Peru. A rock slide dams the Rio Montanero, a long river running through the center of Peru. The whole process takes no more than 3 minutes, which means the landslide moves at a speed of up to 87 miles per hour. It also leaves a trail of debris 5 miles long. The Usoy Dam, Tajikistan. Set off by a magnitude 7.4 earthquake, the rockslide falls into the Murghab River and blocks its flow. That's how the Usoy Dam, one of the tallest in the world, appears. Mount St. Helens, USA. At 8:30 a.m., after much buildup, a volcanic vent finally gives way and sets off a catastrophic eruption, which makes the entire north side of Mount St. Helens fall away. It's the world's largest recorded landslide. North Bonneville, U.S. In the middle of the 15th century, a great earthquake occurs. An incredible amount of debris rushes down from Table Mountain. It covers more than 5 square miles and blocks the Columbia River with a dam 200 feet high and 3.5 miles long. Rocks rolling down the slopes of a rumbling volcano, pushing other bigger rocks on their way, and eventually tumbling down into the ocean in a humongous cascade, causing a wave the height of which the world's never seen before. This is what might happen if the Helena slump of the Hawaiian Big Island falls off into the water. The Kilauea volcano is far from dormant. The latest eruption occurred in 2018. Its eruptions are usually accompanied by earthquakes of different magnitudes, and with each quake, the magma rocks on the slopes of the volcano shift down. These rock formations are called slumps, and the Helena slump is the most notorious of them all. In 1868, the shift of this slump caused a tidal wave rising as tall as 60 feet. But what's most troubling is that some 110,000 years ago, a landslide here led to one of the most powerful earthquakes ever, which in turn led to a mega tsunami of over 1,000 feet in height. Scientists are worried that such an event may repeat in the future. If that happens, the wave might engulf the whole of Hawaii and easily reach both North and South American coasts. Geologists are quick to reassure, though, that a landslide like this is unlikely to occur anytime soon. It's just too early for that. But when it finally does, the consequences will be catastrophic. Have a nice day! Yellowstone National Park in the western USA is world famous for its dazzling views, and especially the colorful Grand Prismatic Spring at its very heart. But we should all stay aware that Yellowstone is, first and foremost, an enormous caldera, basically a slumbering supervolcano. The difference between a regular volcano, like Kilauea from earlier, and a supervolcano is that the latter is thousands of times more powerful. Imagine an eruption spewing tons of huge rock and rivers of hot lava, pumping out clouds of ash that make countries stop air travel for weeks. And now multiply all of this by 1,000. This is what a Yellowstone eruption would look like. At first, a huge area in the middle of the national park would shake, crumble, and then blast upwards in a megaton explosion. Lava flows and magma rocks would cover the area of about 40 square miles, roughly half of Washington, D.C. But the greatest danger is the volcanic ash. The ashen plume would rise miles above and get carried by the wind in every direction. Since the eruption would be far from ordinary, the spread and damage would also be much greater than usual. The ash is thick and heavy, so it would cover a vast area in a blanket, destroying crops and even buildings. Worse still, it would spread in the air and block out the sun, leading to a drastic drop in temperature and an artificial winter. Even regular volcanoes can lower temperatures worldwide by a few degrees. A supervolcano may potentially cause a new ice age. Luckily, the chances of Yellowstone supervolcano erupting in the near future, or at all, are extremely low. There have been only 3 of those in the history of Earth, and there's no evidence such a disaster should repeat. Scientists estimate the probability at 0.00014%, which is lower than the chances of an asteroid wiping us all out. Speaking of which, if dinosaurs could talk, and were at least still alive for that matter, they'd tell you that asteroid threat is as real as it gets. Scientists at NASA say they've tracked 90% of all near-Earth asteroids of significant size, and none of them are a matter of any concern. But there are still the other 10% in the great unknown. What's more, asteroids can change their line of flight because of the pull of other celestial bodies and eventually turn our way. Lucky us. Now, if an asteroid big enough, like a mile across, hits the Earth, it will first cause an explosion powerful enough to erase a dozen big cities in a matter of seconds. Then the impact will raise a cloud of dust and debris that will block out the sun, just like the ash cloud from a volcano, and cause a centuries-long winter on the whole planet. But even if it falls into the ocean, which is more likely, a resulting wave will rise several miles high, washing coastal cities off the face of the planet. But at least there won't be a new ice age. Although scientists are pretty sure there's no such threat in the near future, it can't be ruled out completely, and humanity needs at least 5 years to prepare for this event. If a big near-Earth asteroid suddenly changes its course and turns right toward our planet, we won't stand a chance against it. Disaster movie, anyone? A much more probable calamity, though, rests right beneath our feet. It's the San Andreas Fault in California. The fault has been ready for rupture for years now, and scientists estimate that an earthquake along this line is likely to occur in the next 3 decades. And when it happens, it won't be nice. They expect a magnitude of 8.0, which is comparable to some of the most devastating quakes in history. It's all the more dangerous since California is home to some of the most populated cities in the western U.S., including Los Angeles and San Francisco. High-rise buildings are common there, and they're particularly vulnerable against underground shakes. The San Andreas earthquake might cause a whole lot of damage both to cities and countryside. In the worst-case scenario, the ground might break apart, destroying buildings, farms, and changing the landscape altogether. Still, scientists believe that the probability of such a quake is only 7% for the next 30 years. So there's a rather big chance, 93%, that we'll never see that in our lifetime. Yet, there's another earthquake hazard not so far away from the previous one: the megathrust in Chile. The country sits right above the subduction zone, an area where 2 tectonic plates meet and go one beneath the other. At the place of their meeting, stress is accumulated because of their continuous movement, and once that strain is too much, a major earthquake occurs. Chile has experienced a lot of quakes in the recent years, and scientists are worried those might be preparing the area for a really big one. They believe a great earthquake is due to happen before the end of the century, and it might be devastating to the coastal area. Even smaller quakes caused tsunamis that flooded the west coast, and a huge one like that is likely to raise a wave of incredible height. On the bright side, Chile now knows to prepare in advance for the coming natural disasters, and geologists are pretty sure people will be able to evacuate before the earthquake strikes. In September of 1859, astronomer Richard Carrington was looking at the sun and suddenly saw a bright flare on its surface. He made a note of it in his records, but only realized how important it was a couple of days later. The energy from that flare reached Earth and struck it directly, causing northern lights to appear above Cuba and burning telegraph lines all around the world. This was dubbed the Carrington event, and it was a solar storm. Such storms hit the Earth fairly often, but none of them were so powerful as the Carrington event, neither before nor after. But in 2012, astronomers registered a similar solar flare whose energy nearly hit our planet once again. If it had been just a week earlier, we'd have been in big trouble. Today, humanity relies on electricity in almost every aspect of life, and a powerful solar storm would mess with the electromagnetic field of Earth a lot. All electric appliances would either shut down or short-circuit, and huge transformers powering basically everything would go out of order for good. It would take years to repair them, and the cost of such a massive blackout would count in trillions of dollars. The worst of it is that science is almost unable to predict solar storms, and even if we could know about them in advance, we'd be powerless to stop them. The flare happens in a matter of seconds, and it takes about 8 minutes for the particles to reach the Earth's atmosphere, causing the disturbance. The power outage would come a bit later, in a day or so, when a massive cloud of plasma gets to our planet. At the moment, there's no protection against solar flares, and the chances of one powerful enough to cut all of our electricity in the next few years are quite high, about 12%. The only good thing about all this is that we now know of such a possibility and can at least prepare in advance. Hey, don't forget to pack some underwear and socks. You'll always need those. Floods, tornadoes, tsunamis, hurricanes, yikes. All these natural disasters can get extremely dangerous, but we're kind of familiar with them. But how about a natural disaster that has never happened before, but could occur any moment now? It might be a super eruption. That's what happens when a supervolcano erupts. You might know that Yellowstone Park is located on top of a supervolcano. The last massive eruption there happened about 664,000 years ago, and the one before that, approximately 1.3 million years ago. If we do the math, we'll understand that the next eruption might be due anytime soon. There's no strong evidence that the supervolcano is waking up or preparing for an eruption, but what would it be like if it did happen? Months before the eruption, small-scale earthquakes would become more frequent and more powerful in the area. Not long before the eruption, the growing pressure would push up the ground over the volcano, creating a dome. Narrow cracks would open along the edges of this dome. The magma would then start rising toward the surface, and then the eruption would kick off. A massive column of lava and ash would shoot up into the air to a height of over 16 miles. The volcano would keep pumping ash for days on end. The air in that area would heat up to 570 degrees Fahrenheit. For all living creatures, ash fallout would be one of the most dangerous consequences of the eruption. Buildings and trees would start collapsing under the weight of this dense substance. It would only take a couple of days for a 10-foot layer of ash to cover the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. The eruption would also be rich in sulfur, and this element is an effective sun blocker. That's why it would soon get so cold that there would be no summer in the whole world for the next several years. The monsoon seasons would change. It would be hard for animals to find food and clean water. Well now, how about a gamma ray burst? You don't stumble across this kind of radiation in your everyday life. A gamma ray burst occurs when two neutron stars collide. The collapse of a massive star can produce it too. Gamma rays could present a serious danger to Earth. If a gamma ray burst happened close to our home planet, it could rip our ozone layer away. After that, we would be left unprotected from the sun's ultraviolet radiation. Plus, gamma rays could also produce ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life. Plants wouldn't survive this disaster either. Now, come to think of it, giant sinkholes could swallow entire communities. One of such sinkholes opened up in the city of New York. It pulled a parked van into the earth. That happened in the summer of 2022. And it wasn't the only sinkhole to appear in that area. Local inhabitants reported about 4,000 sinkholes all over the city. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world, which makes them a global problem. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some areas, there are vast areas of groundwater. But during droughts, this water dries up. This creates large empty caverns, and after heavy rains, the surface over such a cavern can collapse, creating a sinkhole within minutes. Now, what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest one to us is 1,500 light-years away. Nothing to worry about, right? Until you find out about wandering black holes. Now, things get definitely way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2012, 13 wandering black holes were spotted not so far away from our planet. But worry not. Not far away, in space terms, means around 1 billion light-years away. So we've got some time left. Plus, the possibility of such a disaster is very, very low. Another natural disaster we haven't experienced yet is a mega flood. It's never happened before, but the changes in climate do make for a risky potential. It could start, let's say, in California. This state experienced some really bad flooding in the past. One of such floods stretched up to 60 miles across and 300 miles long. If a similar disaster happened these days, it would cause $1 trillion worth of damage. It would also uproot millions of people. Now let's talk about a hypercane. Judging from the name, this natural disaster might get extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or because of a massive volcanic eruption. In any case, these conditions could create a hurricane that would stretch way beyond the lower stratosphere. And as you may guess, regular hurricanes don't do that. The hypercane speed would reach 500 miles per hour. The pressure inside would be low enough not to let the hypercane to wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It could damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Now, this disaster did happen before. About 66 million years ago. I bet you know what I'm hinting at. Yep, that very meteor that supposedly wiped out dinosaurs off the face of the Earth. This 7-mile-wide space visitor was traveling at 67,000 miles per hour. As a result of the collision, 75% of all life on the planet disappeared, and winter reigned on Earth for 18 months. Want to know a secret? Meteors strike Earth all the time. Even more of them barely miss our planet. But it's also very hard to predict meteor strikes. Scientists miss a lot of them until they just nearly miss us. That's why experts are working on an early warning system that could prevent disasters. It could make meteor impacts less catastrophic, or at least allow people time to evacuate. It could also be our very own sun that would be responsible for another natural disaster. I'm talking about a massive solar flare. On the scale of damage to society, few catastrophes can compare to this event. It wouldn't destroy buildings like a tsunami or an earthquake. Neither would it end lives in the same way a supervolcano or meteor would. But it would cripple our entire way of life by destroying the whole electronic infrastructure of Earth. The cost of this disaster would reach trillions of dollars. It'd cause other infrastructures to fail – communication, medicine, transportation, banking systems. Those would tumble like dominoes, and it would be incredibly hard to recover them. Earth would be left without electricity for years. There would be no electric light, no computers, no phones. Water supply systems would be out of order. There would be no food in supermarkets. There would be no electricity, and people wouldn't be able to reboot the already broken power grids. In 1859, people all over the world woke up in the middle of the night. It was as light as during the day. The skies were illuminated with auroras, red, green, purple. They appeared even in the regions where no one had seen them before, like the Bahamas, Jamaica, or Hawaii. Telegraphs got electrically charged, even though they were disconnected. In many areas, fires started. That was when technology barely existed. But imagine the avalanche of problems a solar flare could cause today.
Seen a good horror movie lately? If you're a fan of those, then you can appreciate a good plot. But what if I told you that Mother Nature is the best scriptwriter ever? Ancient disasters were scarier than any horror movie today. From tsunamis to volcanic eruptions, you'll be shocked by the scale of these events. One natural disaster you definitely don't want to experience is a tsunami. Those gigantic walls of water sweep across the coast and take out everything in their way. And it's nothing new for our planet. Scientists were able to piece together a timeline based on evidence that major tsunamis left. In northern Chile, a large boulder sits high above the Pacific Ocean. Behind it, a desert as far as the eye can see. This 44-ton stone obviously doesn't belong here. It's the result of an ancient tsunami. Waves as high as a 6-story building carried boulders like pebbles. Researchers estimate this happened in 1420. But how can they possibly know this? In the 15th century, there were no written records in the region. Time for some detective work. Archaeologists discovered that around the same time, there was a tsunami in Japan, on the other side of the Pacific Ocean. The ground shook off the coast of Chile. That's how the tsunami was created. Then the wave traveled nearly 2/5 of the Earth's circumference. That's one tireless tsunami. But this wasn't a one-time event. Evidence suggests that a similar event happened 3,800 years ago. Ancient people abandoned their coastal villages around this time. They were moving inland. How did they know it was time to go? There's evidence of erosion due to strong currents, telltale signs of an ancient tsunami. As you know from school textbooks, oxygen is 21% of the air we breathe, but it wasn't always a part of Earth's atmosphere. Oxygen was missing during the first half of our planet's lifespan. Carbon dioxide and methane were the name of the game back then. CO2 is what makes our drinks fizz. But isn't the other gas dangerous? Yes, because you can't smell methane. And that's the reason there was no life on Earth billions of years ago. So how did we get from methane to oxygen? In come the cyanobacteria. This group of microbes started to evolve some 2.7 billion years ago. These tiny microbes mastered photosynthesis, converting sunlight into energy. And the byproduct of this process was, you've guessed it, oxygen. Soon it started escaping from water into the atmosphere. There, it reacted with methane, and over time, O2 replaced it completely. Scientists named this process the Great Oxidation Event. But how could it be bad? After all, we're alive thanks to it. All that oxygen acted as a poison for anaerobic organisms. And no, these are not life forms that didn't do aerobics or Pilates. The term simply means that these microorganisms didn't need oxygen to grow. Too much oxygen, and they would be goners. And that's precisely what happened. Scientists spoke of an oxygen overshoot that changed Earth's atmosphere for good. The disappearance of most anaerobic organisms was an early example of an extinction event. They didn't like the atmosphere at the time and decided to step down. But look on the bright side. They made room for oxygen-loving humans to enter the picture. Let's go to Turkey. No, not the seaside resorts that tourists visit in the summer, but the region of Anatolia in the southeast of the country. Göbekli Tepe is the world's oldest known temple site. It dates back to the Neolithic period. Scientists found a stone pillar here that tells a tale of an ancient disaster. They presume that the pillar is commemorative. Today, humans still build similar structures to mark an important event or a person. Just one example is the Washington Memorial. It was built in honor of the first American president, George Washington. But the pillar in Turkey doesn't commemorate a happy event. Scientists believe it shows a devastating occurrence, a comet crashing into the Earth. The event must have been destructive. There are also other signs on the monument. These symbols align with the setup of the night sky stars for the year 10,950 BCE. The date astounded the researchers. It matched their earlier research of an ice core sample in Greenland. This showed that a comet fragment hit our planet around the same time. The archaeological site could have easily been an ancient observatory. And whoever worked at it observed a cataclysmic event. The impact must have been so powerful that it changed the Earth's rotational axis. That's the imaginary pole going through our planet from top to bottom. That ancient comet must have packed a punch to knock the blue planet off balance. Have you heard of the city of Tal El Hammam in the valley of the Jordan River? The reason why your answer is probably no is that the city doesn't exist today. It completely disappeared around the year 1650 BCE. It was one of the three major cities in this part of the Middle East. Together, these three cities had a population bigger than Palm Springs today. At the time, Tal El Hammam was a metropolis. It even had high-rises, 5-story buildings constructed using mud bricks. But archaeologists found strange markings on them. The bricks melted as they were exposed to high temperatures. Yes, sound the fire alarm. Some sort of disaster had caused a major fire. Archaeological finds pointed to a suspect for such damage: a rock from space. So, where was the crater? This comet, or an asteroid, never made it to the ground. It was traveling at high speed, so it disintegrated before hitting the ground. Such an event is called an airburst. The largest witnessed meteor airburst happened over Tunguska in the north of Asia in 1908. Scientists estimated that the airburst in Tal El Hammam happened 2.5 miles above the city. This event released a lot of energy. Air temperature quickly rose to 3,600 degrees Fahrenheit. That's hot enough to set clothes and wood on fire in an instant. Mud bricks and tools made from metal start to melt when exposed to such heat. This would explain the evidence scientists unearthed. But there was one more find: salt. The event was so powerful that it distributed salt over the region around the Dead Sea. Any farmer will tell you that salty soil and crops don't go well together. People started moving away from the area because they couldn't grow food. Imagine an island with whitewashed villages surrounded by a sapphire blue sea. Such a place exists in reality. It's the island of Santorini. But the history of this place hides a tale of destruction. The island is of volcanic origin. This means that a violent eruption created it some 3,000 years ago. Now there are two islands. The bigger one is shaped like a horseshoe. When you look at them from above, the two islands look like they form a circle. That's because they were once a single island. It had a large mountain and was round in shape. But then it all changed almost overnight. One of the largest volcanic eruptions in human history tore Santorini apart. The earth trembled, tsunamis formed, and clouds of ash filled the sky. A daunting image. People felt the eruption hundreds of miles away. When it was all over, seawater rushed into the caldera of the former volcano. That's why the water in the lagoon has such a beautiful color. Scientists know so much about Santorini's past because of an unlikely assistant, a tree. The juniper tree, to be exact. People use its aromatic wood for everything from furniture to making pencils. On the Greek island, its rings revealed the tale of the ancient eruption. As a tree grows, it doesn't only go up, it expands sideways as well. Each new layer of bark adds a ring to the trunk. It takes a year for one ring to form. And on Santorini, one ring was unnaturally pale. The scientists did the math and voila, they dated the eruption to 1560 BCE.
It only takes a moment for a routine flight to turn into a gripping survival story. In a world where a wrong button or an unexpected gust of wind can lead to a disaster, adhering to safety rules is crucial for everyone. From buckling seatbelts to raising window shades during landing. We got all these rules learning from our mistakes. Stay tuned to find out more. A flight had a crazy mid-air moment in 1993 when the pilot accidentally deployed the wing slats, the part on the leading edge of the wing. Now, the weather was fine, passengers were relaxed, everyone was doing what they wanted. Suddenly, they felt an unexpected jolt. Instantly, the autopilot disengaged. The captain started wrestling with the controls. The plane became wonky, pitching and rolling dramatically, resulting in a rapid descent of 5,000 feet. The vibration threw the cabin into total chaos, with passengers screaming in fear. The slats were only to be used during takeoffs and landings, not in midair. It was China Eastern Airlines Flight 583, cruising over the Pacific on its way from Shanghai to Los Angeles. The pilot declared an emergency and directed the plane to an Air Force base in Alaska. Out of the 255 people on board, 60 ended up in a hospital, and sadly, 2 didn't make it. The pilot made some quick moves to stabilize the aircraft, but the injuries happened because folks weren't buckled in. They reckoned that the slats deployed because of the design of the control handle. The company was to blame for that. They produced it in such a way that the handle could accidentally get jiggled while cruising. Luckily, the crew was trained, and the airliner itself was fine, except for the messed-up cabin. The aftermath of this incident was costly, requiring about $1.5 million to repair the damage. When the plane started to lose altitude, overhead lockers burst open, and the safety video played 3 times for an eerie touch. Once the aircraft steadied, flight attendants jumped into action, providing first aid, leaving empty kits scattered in the cabin. It turned out that the poorly designed slat control handle had caused 11 similar incidents before. The captain probably nudged it accidentally while fixing the speed controls. The lack of pilot training on high-altitude issues and the stall warning system made things worse. If the passengers had kept their seatbelts on, injuries would have been way less severe. This has been the case during many other accidents. You probably know this airplane announcement. Even when the seatbelt sign is off, buckle up when you're seated. Experts say it's a good call. While flying is safe, keeping that seatbelt on is smart because you might hit unexpected turbulence. It's about keeping you secure during that bumpy, jarring time, especially that sneaky one during stormy weather. Sarah Wilson, the president of the Association of Flight Attendants, thinks the seatbelt sign should be turned on throughout the entire journey. Predicting turbulence is like trying to guess the weather. It's not 100% accurate. Turbulence can happen anywhere. Aircraft are tough. They can handle really bad turbulence. The real risk is getting injured during turbulence, not planes falling apart. It's rare, but accidents still happen. In a dramatic episode in 2016, a pilot pulled off a superhero move, saving 439 lives. He was getting ready for takeoff in Shanghai. All of a sudden, another plane showed up on the runway in front of him. Reacting with lightning-fast speed, the pilot swiftly elevated his plane, narrowly avoiding a disaster. The pilot was awarded $360,000 for his remarkable skills. He missed the other plane by less than 67 feet, about the length of a semi-trailer truck. It turned out that the air traffic controllers and the landing crew had mixed things up. 2 controllers lost their licenses, and 13 others got in trouble. They say this incident was like a throwback to the Tenerife airport collision in 1977. Back then, 2 jumbo aircraft collided on a foggy runway. They didn't get lucky that time. The incident was a total disaster. Certain accidents in aviation history prevented others. With each crash, something crucial is upgraded. In 1956, 2 planes collided over the Grand Canyon, resulting in the tragic loss of 128 lives on board. This accident kick-started a $250 million air traffic control system enhancement. The Federal Aviation Agency also appeared in 1958 to keep an eye on air safety. Then, in 1986, a private plane accidentally entered the Los Angeles control area, colliding with another aircraft. This tragedy took 86 people's lives. In response, collision avoidance systems were introduced. In 1978, United Flight 173 faced a landing gear problem. This led to a crash that claimed 10 lives. This incident triggered a transformation in cockpit training, introducing cockpit resource management. This management method shifted away from the traditional captain-centric approach to emphasizing teamwork and communication among the crew. Another upgrade was about averting in-flight emergencies. In 1983, Air Canada Flight 797 had smoke in the rear lavatory, which led to an accident that took 23 lives. The FAA responded by requiring smoke detectors and automatic fire extinguishers in aircraft lavatories. Post-1998, planes got retrofitted with fire-blocking seat cushions and floor lighting, with newer ones adopting flame-resistant materials. Winds can be dangerous in certain circumstances. The crash of Delta Flight 191 in 1985 brought attention to the dangers of wind shear. Research efforts by NASA and the FAA led to the development of forward-looking radar wind shear detectors. By the mid-90s, these became standard on airliners. The number of wind shear-related accidents has reduced significantly since then. In 1985, United Airlines Flight 232 faced a nightmare when the DC-10's engine failure left it virtually uncontrollable. Pilot Alfred Haynes landed the plane at a nearby airport, but the subsequent fire was terrifying. 185 passengers survived the catastrophe. The root cause of the incident was a crack in the fan disc, which occurred during the manufacturing of the titanium alloy. This incident prompted the FAA to modify the hydraulic system, implement redundant safety systems in future aircraft, and revolutionize engine inspection protocols. In 1988, a big chunk of an Aloha flight's fuselage ripped off in mid-flight. In an instant, the cabin was torn open, leaving the passengers exposed to the open sky. Despite the chaos, the pilots managed a safe landing, with only 1 fatality. The NTSB found that corrosion and fatigue damage, which had accumulated over 89,000 flight cycles, had caused this accident. The plane had been used for short-hop pressurized flights between the Hawaiian Islands. Shortly after, the agency initiated the National Aging Aircraft Research Program in 1991. This program tightened inspection and maintenance standards, especially for high-use and high-cycle planes. About 80% of mishaps happen in the first 3 minutes after takeoff or the last 8 minutes before landing. Keep your eyes peeled during these times, and your survival chances will go up. Now, don't let that freak you out. The odds of actually getting into a plane crash are like 1 in 11 million. That's the same possibility as being struck by lightning in a given year in the United States. Planes, on the other hand, often get struck by lightning, but they're built to handle it. Each plane probably gets zapped about once every year or every 3,000 hours it's up in the sky. But there hasn't been a lightning-related accident since 1967. Engineers have ensured that when a plane gets hit, the lightning just zips right through it and out, without really messing up anything inside. Let's delve into the fascinating mechanics of how planes stay airborne. The wings are important, but it's not just about them. There are 4 forces at play: lift, thrust, drag, and weight. The little tails on the ends of wings are called winglets, and they help reduce air swirls, making the aircraft slicker and faster. There's a reason why lights dim when a plane lands at night. It prepares everyone for a quick evacuation, helping the eyes adjust to the dark should the landing go awry. You're in a bright room filled with obstacles, and suddenly the lights go out and you're asked to dash for the exit. Tricky. Flight attendants also ask you to raise those window shades during landing. In case of an emergency, they want you to be able to see what's outside and figure out if one side of the plane is better for a quick escape. If you're wondering where the safest spot in an airliner is, it's in the back. According to research conducted by Popular Mechanics, spanning from 1971 to 2005, sitting in the back gives you a 40% better shot at making it through an accident. Almost as importantly, you're closer to the restrooms.
Marriage is not only about happiness, mutual support, love, and friendship. Marriage is also about trials, crises, and storms. And this Swedish couple survived several storms during their honeymoon. Literally. Not screams, insults, and drama, but real hurricanes, fires, earthquakes, and other natural disasters. This is a really cinematic love story. Newlyweds against nature. Meet Erica and Stefan. They met in Stockholm while working on a joint project, parted, but started chatting with each other on social networks. Their long-distance communication lasted for several years before Stefan decided to ask the woman out on a date. And it's worth paying tribute. It wasn't a typical date in a restaurant or in a park. Stefan suggested that Erica fly with him to go diving in Egypt. They realized that they both loved to travel and finally fell in love with each other. After a fabulous wedding and the birth of a beautiful daughter, the couple decided to go on a 4-month honeymoon. The tour was impressive. From Sweden to Indonesia, then to Australia, New Zealand, Japan, and China. They didn't expect that the trip would turn out to be a real adventure where safety was not guaranteed. At first, they got stuck at Munich airport. All flights were delayed because of a severe thunderstorm. In Bali, Indonesia, they went to a high mountain with their little daughter. A strong wind began to blow at the top. It tore off the roof of the tourist bus where our heroes were sitting. Fortunately, no one was injured, and there were no other problems. But at that moment, it was just a teaser of the coming disasters. The couple arrived in Australia, where a wildfire first started near the city of Perth. Stefan and Erica didn't want to cough up thick smoke, so they quickly left for the city of Cairns. It was during that period when a ferocious cyclone began there. The storm was so strong that the Australian Red Cross Service provided shelter for 2,500 people in the mall. And there, another problem began. Imagine 2,500 people in a big, hot room without electricity while a hurricane is raging around. Oh, and there were only 5 toilets in the entire building. How nervous do you think people were? Eric and Stefan recall that some guys started fighting because of stress. The tension was getting stronger, but fortunately, the mall guards kept the situation under control. Wildfires, hurricanes, it seems that something is missing. Oh yes, what about an earthquake? The couple faced 2 earthquakes during their honeymoon, one of which happened in Japan in 2011. They went through all this together with their little daughter. Just imagine how their daughter was amazed by all these adventures. Such a trip strengthened their marriage. Of course, after natural disasters, any domestic quarrel would seem like a mere trifle. Erica admitted that in crisis situations, Stefan fully justified her trust and behaved as she had hoped. Oh, how sweet. What if we create tours for married couples who are planning to divorce? Survive the storm, fire, earthquake, and flood together, and then think again whether you should leave each other. Imagine that you've gone through several natural disasters in your entire life. Now the question is, are you lucky because you've survived, or are you an unlucky person because you've run into such troubles? It depends on how you feel about it. For example, there's a woman, Dana Weiland, who lives in California. She has survived several disasters throughout her life and continues to smile. And more recently, she's faced another disaster, wildfires in her home state. But let's take it in order. In 2005, Dana Weiland lived in New Orleans, and if anyone doesn't know, that year, Hurricane Katrina destroyed many houses in this and other cities. Dana's house was no exception. According to her, the lower floor of the house was completely flooded with water. Of course, she had to give up everything and evacuate. Dana and her family drove to Texas to a friend's place for about 20 hours. 1 month later, Hurricane Rita arrived there, and Dana and her family evacuated again. It looked as if nature was following her around, but our heroine was not one of the timid ones. Several years later, she faced another disaster, Snowmageddon. This was when a huge amount of wet, cold snow flooded cities and roads. Strong wind, blizzard, and endless snowfall. All traffic stopped. The lights turned off. The streets were empty. Dana sat for 11 days without electricity during this snow apocalypse. And after all these disasters, she got the exact opposite of snow. Wildfires in her hometown of Lake Arrowhead in San Bernardino County. Let's hope that this time, everything will be fine with her again, and she will meet any adversity with a smile on her face. Have you heard that lightning doesn't strike twice in the same place? Can it hit the same person twice? What if it strikes the same guy 7 times in a few hours? This is not a movie plot in a tragicomedy genre. This is the real story of Roy Sullivan, a man who got into the Guinness Book of Records for the number of lightning strikes survived. There are more than 8 million lightning strikes on Earth every day, which is about 100 strikes per second. But even so, the probability of getting struck is extremely low, 1 chance in 10 million. For Roy Sullivan, these chances were too high. For his strange record, people nicknamed him the Human Lightning Rod. For the first time, lightning struck him in 1942, when Roy was on a watchtower that didn't have a lightning rod. A bright flash of light and a powerful current discharge scarred the man, but didn't cause crucial damage to health. The next accident occurred in 1969, when lightning struck a tree near the road. The lightning passed through the tree to a car. Guess who was driving this vehicle? Roy lost control and almost drove off a cliff. Fortunately, he stayed alive again. Okay, the first time he was on the tower during a thunderstorm. The second time was on the road next to a tree, and as we know, lightning often strikes trees. This meant Roy was in a potential risk area every time. But the third time happened in his front yard. Lightning struck the transformer and caught his shoulder. The fourth time happened in 1972. Lightning struck Roy while he was working. From that moment on, the man began to suspect that this natural phenomenon was somehow attracted to his body. Maybe it was a curse, or maybe everything could be explained from a scientific point of view. A year later, lightning struck him for the 5th time. A thunderstorm started that day. Roy decided not to try his luck again and hid in his truck. And so, when the storm calmed down, Sullivan got out of the car and bam! Another lightning strike. There were 2 times left before the record. They occurred in 1976 and in 1977. Roy's bad luck spread to his wife. One day, lightning struck her too. It didn't hurt her, but scared a lot. So far, no one has broken Ray's record, but obviously, people haven't tried to do that. Okay, lightning, fires, snowstorms, hurricanes, and earthquakes. But how about tsunamis? Unfortunately, this is one of the most terrible and devastating disasters on the planet. If you survived it, you're definitely lucky. Zarul Fuadi from Indonesia survived these devastating water disasters twice. The first occurred in Indonesia in 2004. And the second happened a few years later during an earthquake in Japan. During the second time, Zarul was in the building on the 3rd floor and felt a jolt. He was shocked and immediately remembered the tsunami he had experienced before. The tsunami hit the city, but our hero and his family survived. After this double trouble, he decided to move to his homeland, Indonesia. Despite the terrible events, Zarul looks at what happened calmly. Any catastrophe can happen to any person at any moment, but it doesn't mean you should live in fear forever. So, he focused on the bright side of life.
If there were cataclysms on Earth every 5 minutes, living conditions on our planet would be almost the same as 4.5 billion years ago. Back then, seas and oceans boiled, Lightning struck everywhere, tectonic plates changed their shape, lava flowed from volcanoes, and worse, no internet. The Earth resembled a vast boiling cauldron where life was gradually being created. If it starts to boil again, this cauldron could destroy almost all life on the planet. Consecutive cataclysms. Won't hurt to pretend. Let's imagine, shall we? Good morning! You wake up in a small underground bunker. The seismic sensor indicates that a 7-point earthquake will start in a few minutes. You pack a huge waterproof backpack and go upstairs. The underground bunker is protected from seismic activity. It moves with the ground, so you're safe here. But you need to leave the shelter because supplies are low. Also, yesterday, you picked up a radio signal telling all survivors to go south immediately. The coordinates they gave aren't far from your location. You have to hurry, though, before the landscape changes again. You open the hatch and find yourself in the middle of the desert. The sun is almost invisible beyond the gray sky. The ground is shaking, but you're not afraid. There are no houses or buildings, nothing to fall on you. You keep your balance perfectly, and the earthquake doesn't knock you off your feet. It's like jumping on a trampoline. The only danger is the deep chasms in the ground, but you can easily jump over them. After such an extreme morning warm-up, you decide to have breakfast. You take a tin can out of your backpack. You have a few minutes before the next disaster, so you eat and remember how your great-grandfather told you how all this started. Before all of this, the planet was divided into territories called countries. Millions of people lived in them, and then something terrible happened. The tectonic plates started to move, and the air temperature and atmospheric pressure began to rapidly change. In one day, earthquakes destroyed entire cities. Tsunamis and floods washed away the remaining ruins. Volcanic ash blocked the passage of sunlight. Forest fires destroyed almost all vegetation, and eruptions poisoned the air. Only a few people managed to adapt to such harsh conditions, and you are a lucky duck to be one of them. As you finish your breakfast, you're distracted by another ground tremor. Time to move on. Many people travel around the world alone, as they consider it a safer way of life. Some people form small communes, but no one ever stays in one place for too long. Your whole life is in motion, but you don't panic. One of the main rules during natural disasters is to remain calm, so all survivors have steel nerves and excellent physical training. You run a few miles south and suddenly smell something strange. You put on a gas mask. The earthquake has created a limnic eruption. Natural carbon dioxide is released from the ground to the surface. You feel comfortable in a gas mask, but can't run fast while wearing it. Far up ahead, you see a green forest, a rare place that was not affected by fires. You take off the gas mask and go to the tree to take shelter in the shade from the scorching sun. This green area is rich in vegetation. Colorful flowers, strawberries, and many other berries grow here. But you're concerned. Such fertile land comes from being near volcanoes. It spews underground magma rich in vitamins and minerals, so vegetation grows. You can see a high mountain in the distance. This is the volcano. An underground push occurs again and provokes an eruption. You gather strawberries and run away from this place as far as possible. Lava pours from the volcano's mouth and makes a fire in the forest. You unhook a folding scooter with a motor from your backpack and drive away from the fiery mountain as fast as you can. The sky is covered with volcanic ash, but this is not for long. A strong wind grows with each passing second. You realize a hurricane is moving in your direction. You take out a small shovel and dig a hole in the ground. The soil is dry, but you have enough strength to dig a small ravine in a couple of minutes. You dive into the shelter and cover yourself with a protective tent. The hurricane blows the volcanic ash in different directions, and the air becomes clear again. But the fire doesn't stop. The wind spreads through the forest. You get out of the ravine and put on the gas mask again. There's a lot of smoke around, and it's unbearably hot. You know the hurricane couldn't just appear without any reason. Hurricanes are formed when warm, moist air collides with the sea surface and rises to the sky, so there's water nearby. Great, because you're thirsty and want to cool down. A loud sound erupts behind you. You turn around. A massive wave of water approaches the fire. Without panic, you take your life jacket out of your backpack, remove your gas mask, and put on a diving mask and fins. The wave blows you off your feet, but you don't drown. Over the years of survival, you have learned to swim very well. You grab a passing tree and wait patiently for the flood to be replaced by another natural disaster. For 5 minutes, you sail under a black, stormy sky that sparkles with lightning. Despite the waves, you try to row south. It's getting pretty cold. You finally see the shore, but this is not a land, but ice. A strong wind brought a cold cyclone, which caused a fast temperature change. It's like you're in Antarctica. Snow and blizzards are all around. It's freezing, but you take out a thin space blanket made from foil and walk slowly south. Under your clothes, you put crumpled paper, bubble wrap, pieces of cotton. All this also helps to warm your body. Along the way, you collect several bottles of snow to melt later. Icicles form on your face, and you can't see because of the snowstorm. Suddenly, the snow begins to squish under your feet. The ice melts and turns into water. A hot stream of air blows into your face. You find yourself on hard, dry ground, looking up at the sky, then at your watch. 5 minutes pass, and the sky is again covered with black clouds. You take a metal plate out of your backpack and cover your head with it. A few seconds later, you are hit by heavy rain and hail. Giant balls of ice knock on the metal shield, but you go calmly and even with a smile on your face. The ground becomes wet and loose from icy rocks. When the hail ends, you pull out all the heat-insulating materials from under your clothes and hide them in your backpack. Then you lay out a few long spokes of steel. The spokes are wrapped with copper wire. You connect the spokes to each other, making one long antenna. You stick it in the ground and run away. After the hail from the rain clouds, lightning strikes the ground. More precisely, it hits the lightning rod you've just built. You wait for the storm to end, then take the lightning rod apart and return it to your backpack. An intense heat begins. You drink some melted snow and break your way through the desert. The earth trembles, and your adventure begins again. Earthquakes, carbon dioxide, fires, floods, snowfall, tsunamis, lightning, and again and again and again. With the help of a compass, you continue your journey and reach your goal a few months later. You see a long antenna sticking out of the ground. This is a place mark for entering an underground city. The city is built from dozens of massive bunkers connected to each other by tunnels. The city walls don't allow radiation to pass through, and they don't bend from daily earthquakes. People learn to extract energy from the ground. The Earth's core gives heat. This heat boils water, then steam is formed, and electricity is created at special stations. People get water from underground lakes and rivers. Instead of the sun, ultraviolet lamps are installed everywhere, which provide people and plants with necessary light. Natural disasters happen on Earth every 5 minutes, but humanity still has a lot of space underground.